All right, sorry guys. That was unfortunate timing. Okay. All right, you ready? Press down to go to the next slide.
Just give me a second. Real quick.
I'm calling you on Discord. Oh, by the way, if you guys are in the stream, I had technical difficulties. My Mac decided it was a great time to have an update right before. Mute. Yeah, let me mute myself actually. Hold on. Okay. Yeah, you guys wouldn't think it, but I literally started prepping for this like an hour ago, and it was. I hate Apple. Let's put it that way. Okay. All right. We should be good now. You ready?
One more second. Sorry guys. Just trying to clean up my system. Have a fresh, clean demo for you guys.
Don't worry about it. Let's just start.
Okay. Just start real quick.
Yeah,
If anything, I'll just make it a different name.
that's fine.
Alright.
All right, go for it. Press down.
No.
This one.
Down.
To go to the next screen. Yeah.
Okay.
All right.
Well, keep it notes for me.
Yeah. Wait, notes? I don't have notes on here, to be honest.
Yeah, we do. Put the notes. I need notes.
I don't know how to get you the notes, man.
Do it to like when you're doing like a presentation mode.
I can't do that on here now. I can't do that. I'm sorry.
Let me do that.
All right. Do you need the notes?
Yeah.
Do you need the notes, or do you think you need the notes?
I need the notes. I'll just have them on my PC real quick.
Okay. Trust me, I prepared great slides for this. This is probably one of the most important things that I've learned. I was a project manager this summer for a machine learning company, and this is what I learned in my internship. So if you guys are, worried why this is taking so long, it's just because I spent literally 9 hours on the slides today and 12 hours on the slides yesterday. So I'm sorry about that. But yeah, my name's Kyle. This is
Hey guys, I'm James. I'm with ACM. I'm the workshop lead over there. I'm the only true. I'm the only officer present at the moment. Currently, everyone's studying for midterms or they're just busy with other classes. But yeah, I hope I can give you guys the best presentation possible. Quick note: this is my first presentation, so like I'm a little nervous. So bear with me. And I'm not an expert with Docker, but I've been like researching diligently, and I've actually interned at Circle CI. So they're like a DevOps company that focuses on like continuous integration and continuous deployment. And I kind of worked with them as like an intern, and I kind of like worked on like a React project that would like kind of abstract the building process from like coding it on like YAML, which is like a configuration language for like building pipelines, to like a React app. So that's kind of what I did. But yeah, let's get it started. Yeah, so the agenda for this workshop. So first we talk about what's Docker, who's the company that owns Docker, the creator, and some of the cool technology behind Docker. So the next thing we'll be talking about is why you should use Docker, some of the pros and some of maybe the cons, and some like use cases for it, in some cases not to use Docker. And then lastly, we'll be Dockerizing a React app, so that'll be our demo. So yeah, let's get started. So what is Docker? So Docker is a developer operations tool. So it's used to manage, maintain, and deploy applications and software. Docker is also used as a container technology. So container technologies are kind of like virtual machines, but the thing is they don't virtualize the whole hardware. So it's a lot more lightweight and faster than a virtual machine. Yeah, so Docker is used to create isolated environments for software. What else? We have microservice technology. So like microservice is like a philosophy in software engineering where you have like an application and you have like a monolith application where it's like in one architecture. But microservicing is like when you're splitting up all the services of that application into different parts. And Docker is used to create all those isolated environments for each of those services. So for example, let's say you had like a food app and you had like a database for like the orders and like another service for the payments. And let's say your payments went down. If you were working with like a monolith application, then it would be kind of hard to redeploy because you would have to like shut the servers down, update everything, and then also it would take a long time to redeploy. But if you microservice, you can actually decouple all your services into separate containers where you can like actually redeploy a certain service pretty quickly and not have to redeploy the entire architecture. Yeah, and also dependencies. So when you have a lot of dependencies on your computer, like you have like a lot of libraries, some of them like are out of date and some of them can like, cause conflicts when you're trying to like develop, and that can really slow down on your development process. So Docker is really helpful for, accelerating your development process, or just like coding. And also, like I just said, Docker is a container technology. There are different applications that use the container technology for isolating environments, but Docker is like the go-to container technology. So who is Docker? So Docker was originally .cloud. They were like a cloud service provider, but now we have like Azure, AWS, and a lot more other providers, and they're kind of like out-marketed, and they kind of like went bankrupt. But their cloud service used the container technology, and their founder, Solomon Hykes, said, you know what, let's focus on containers, and that became their niche, and they focused on that, and they're pretty successful now. So like, people, you tend to think of Docker as like a synonym for containers, and Docker comes from the word dock worker, which is like, you see these ships, you have a bunch of containers. During the 1960s, the invention of all these like big containers and just like, accelerating that process of shipping goods across the seas was really big with like importing foods and different products. So that's why, that's where Docker gets their inspiration from. Yeah, so a little bit about the Docker container technology. So you have physical servers, virtual machines, and containers. So physical servers are good for dedicated resources for a specific application, but the problem is they're hard to scale and they're pretty expensive with computing costs. So because of that, companies started to use virtual machines, which are like virtualized hardware. But the thing is, they're pretty slow when it comes to boot up time, and it's kind of hard to redeploy them. It's kind of hard to share them with other developers and have them work on that specific product when they're developing. And then lastly, we have containers. So containers are kind of like virtualized OS systems where you don't have to virtualize the hardware, like the sockets and the CPU and all that stuff. You kind of like just virtualize on top of the hardware. So it's pretty good because it has the faster spin up time and it's easily scalable. So it doesn't take that long to deploy, and it doesn't take that long to build up. So that's why we use Docker. And yeah, so what are images? So images are kind of like software or projects that companies or any developer can make. So they're kind of like I just said, like an isolated environment. space for your project to be in, and images are like the templates, and containers are like the running instance of an image. So images are like Node.js or MongoDB, and Docker actually has like a repository for all like images. So they have images that are made by like professional companies, and you also have images that are made by like just regular developers. And you can also make your image like public or private, depending on your needs and what you're trying to do. So yeah, you have Docker Hub. So if you're interested in any like images or exploring all that stuff, you can just head over to Docker Hub and get started over there. Yeah, so
Oh,
now,
actually, 1 second. I just realized the stream was broken. Sorry. It's not showing the whole screen. Go ahead. I'm just gonna fix it real quick.
oh, I can't see the slides.
Oh, my bad. Crop right, crop 0. My bad. Okay. Why is this not locked? I'm sorry, guys. I did this completely differently last time. There we go. Okay, it should work now. Okay. All right, there you go.
All right, so let's get back to it. So we're talking about why we should use Docker. So here are some of the problems that Docker solves. So if you're using your base OS, it can get kind of like disorganized, like a drawer. Maybe you have like a drawer for clothes and stuff, and you just add like socks and shirts and pants. But like if you have a drawers, or like you just want to like have each clothes, or like each, like, you know, if you have a shirt, you want it on the top drawer. If you have your pants, you want it on the bottom drawer, and if you have socks, you want it in the middle drawer, however you want it. And Docker kind of just organizes all that for you. So they kind of like get rid of all like the tangling of all like the dependencies on your computer, and they kind of like split it up into like different isolated environments where you don't have to worry about getting dependency conflicts with your software projects. The next thing Docker does is it improves the portability of your projects. So like if you deploy your project, a different developer doesn't have to go ahead and reinstall all those dependencies. And also if they're like working on like Mac, they don't have to worry about installing stuff you would need for Windows, and vice versa. And because of that, because Docker's kind of like a virtualized OS, it acts as its own OS, so you don't really need to worry about the differences between Mac and OS or Linux. And another thing is Docker, because it's like an isolated environment, it's like a jail cell. So nothing comes in, nothing comes out, and it just contains all that software. So like if that software had like some malicious code, it wouldn't infect your base host system, being your PC or whatever. Some of the use cases for Docker, like I said, you can use it to learn new technologies. So it's like an isolated space where you can like mess around with stuff and not have to worry about downloading something, like mess up the other software or whatever you have on your computer. And it's used for app isolation, and it's used to increase the productivity of developer teams. Like you can see here, we have like these diagrams. Like you see how all these libraries are kind of like mixed up together, and it's kind of complicated. But Docker kind of like separates all of them and makes them more neat and organized. So yeah, an overview of Docker. So here's like a workflow of Docker. So yeah, so if you have a base image, let's say we're working on a JavaScript app and we want to use MongoDB, so we can go grab the MongoDB image from the Docker Hub, and then we just want to develop that JavaScript app and like an isolated Docker container. And then once we're done, we can just build it and deploy it to like a CI/CD platform, whatever. It can be like Circle CI or Jenkins or whatever platform you're using. And that CI/CD platform will build it, and it will send it off to the Docker repository. And then whatever server you have can like pull that image and then host it onto their server. So that's kind of like a speed rundown of like the workflow of like using Docker in a project. So now I'm just gonna be doing like a demo of Docker. I'm just gonna show a couple commands and how to build an image. Oh, before I do that, when installing Docker, you want to install the Docker desktop. So that the Docker desktop is like the UI for Docker. It's like abstracted on top of the command line interface for Docker. So you can do a lot of stuff without having to type in the commands. But I would highly recommend using the commands. It's just better to like get the feel of that, and you can probably do a lot more with the command line too. So, and yeah, I'm gonna be doing the demo right now. Sorry.
Okay. I used to check and see what's wrong with this. Why is it doing this? Why are you like this? I don't know why it's cropping off like half the screen. Whatever, we'll just deal with it. Okay. So you join the. Are you sharing your screen?
Yeah, let me share my screen right now.
Go for it.
Ready. All right. You see it?
I think so. Let me check. Yeah, it looks like it. Yeah, you can see it.
Is there a way you can see how it slides up? Let me go ahead and do it.
Not really. Oh yeah, you can have it like that.
Yeah.
Okay.
All right, I'm just gonna go ahead and start the demo. So for this demo, we're just gonna be pulling an image from the Docker Hub. So to pull an image, you can just like look up whatever image you're trying to find, and we're gonna be using the Nginx image. It's pretty much like a server image for running like applications. I'm just gonna use it to test run the Docker commands for you guys. So we can just go ahead and pull it right now. All right, so now we have the image pulled. We're just gonna, get a list of all the images. So we're just gonna do just command Docker, and we're just gonna do images. I do have other images I was working on, but the image we're gonna be focusing on is Nginx. As you can see, we have the name of the image we're using, and we have the tag. So the tag kind of like just displays which version of the image you're using. So as you guys can see, we're using the latest version of Nginx. And then we have the image ID, which is like the unique ID for the image. And then we have the time it was created. So I've been working on this image since 2 weeks ago. And we have the size of the image also, which is like 142 megabytes. Yeah, so we're gonna go ahead and run the image. Alrighty. As you can see, we have the image running, but the thing is, it's kind of like attached to the actual terminal. So we want to detach that image from the terminal. So I'm just going to be running a different command. But before we do that, we can also see the process list of all the processes that's running, which means like all the containers we're running on our Docker setup. Oh yeah, and keep in mind when we run an image, it turns into a runnable instance of an image, which means it's a container, and that image converts into a container. So right now we have a container running on our machine right now. And as you can see, we have, I guess I was working on a different image, but the Engine X is currently running, as you guys can see, and we can also go to the Docker Hub or Docker Desktop to see where it's running. We can also see it's running in the Docker Desktop, so it's a little UI for you guys. Let's go ahead and detach the image from our terminal. So we can just do Docker stop, and then we're just going to be stopping the container like this. So you just want to grab the container ID, and it will just stop that container. And then we also want to do Docker run, and then we just want to detach it. And also, when we want to serve our image locally on our machine, we have to give a port to it. So we just use this command -p to add our port to listen to that container. And the containers live in, I think, 3000. You can also see the container port. Okay, sorry guys. Let me try again. So I'm just gonna run it in detach mode again and show you guys where you guys can find the ports running in. Give me a second. And we can just run this command called container ls to see how the containers are running. There's the port. Yeah, so it's running in port 80. So we're just gonna stop it again and try to connect that port to our local machine. Yeah, so we can just run the command docker run -d to detach the image from our terminal, and then -p, and then 3000 because we want to serve it up to the port 3000, and then add the port of where that container is at, which is 80, and then we want to add the image after that. Yeah, so now we can just go on localhost 3000, and here you guys go. That's our image, our container running on our localhost. Okay, now we're just gonna be doing the demo with the React app. So we're gonna containerize the React app. So let me go ahead and pull it up for you guys. So as you guys can see, when we're making an image, we want to add the actual scaffolding of it. So we'll be adding like the commands for the build process of the image. So the first thing you guys want to do is that you guys want to do like the from command, so that lets us know that's our base image we're working with. So we're using Node because we're working with a React app, and this is like the starting point of the image. And then we also want to add the working directory of the image. So when you start the container, so this is the working directory, this is the name of it. And then we just want to copy some of like the other things we need, which is the package.json, which contains all the other packages. Then we want to run npm install. Then we just want to copy all the contents from the actual project I'm working in right now into the container. Then we just want to expose that port to 3000. And then these are the commands we want to run when we're like trying to run a React app. So we're just going to list them all in an array here with the command cmd. So right now I'm just going to go ahead and build the image for you guys.
Can you just do command plus real quick? Control plus.
Sure. Oh, sorry. This helps you guys see it a little bit better. I'm just gonna clear everything. So first thing is we want to be in the actual directory where the Docker file is. So we're in the Docker file right now, so we can just do ls to see where we're at. Yeah, we can see the Docker files in here. Then we'll just go ahead and do Docker, and then build, and then we also want to add this command called -t to add the tag to it, so we can, let the Docker engine know that we're running on like a latest version or whatever version we want to run it on.
You talked to that, sorry.
Oh, sorry. First time, sorry about that.
No, you're good.
Yeah. Yeah, so we'll just like, first thing is, we'll give it a name, so we call it sample, and then we can just make the tag latest. And then we wanna also add this, this dot notation here, so we can let the Docker command know that we're pulling everything from the current directory we're at. And yeah, we're just gonna let that load up.
There we go.
And yeah, there we go. We have a built image. We can actually see where the image is at. So we can just do Docker images. And as you guys can see,
Sample.
yeah, I did sample latest. Oh, is it in here?
Yeah, it's this top one.
Top one. Yeah, I guess it's right here. Here's the tag. Yeah. Sorry about that. And yeah, we're just gonna run that sample image, convert it into a container, and then run that container on our local host to display the React app. So we just go ahead and do Docker run sample latest. So when we're specifying the tag, we just want to add the colon and then the tag right after the name of the image. And also, sorry about that, we actually want to detach the image from our terminal, and also give it a port to have our local host listen to that specific port where the image is on. Yeah, so it's in the port 3000, so we're just gonna connect to that. Oh no.
It's already allocated. Just change the first one to 3001.
All right. Yeah. I guess we're already using that port. Sorry, guys. All right, there we go. Let's go ahead and open up that port or React app. So just do localhost 3001. Just give it a second. Try it here. Oh. All right, there we go. It's running now. And yeah, that's how you build an image and run it on your machine.
Nice.
All
right.
Yeah, so that pretty much wraps up the demo. I'll just probably bring it back to the slides.
That's fine. No. That's good. All right. So, sorry about this again. Let me just try this real quick. Display capture. New display capture 2. We just go like this. All right, we're gonna go like this. All right. Now we're good. Okay. Let's go back to this. All right, so where are we on my part?
Yeah, let me just go over the resources real quick. So if you're interested in learning more about Docker, you can just refer to the Docker documentation. You can also watch Solomon Hike's talk about Docker. He kind of goes over the philosophy about Docker. And then you can also go on this link, dockercurriculum.com. It's kind of like a web course about Docker. So yeah, if you're interested, just check out those resources.
Awesome, thank you. Thank you,
Yep.
James, I appreciate it. All right, so now let's go talk about Docker for ML deployment. So today we're gonna be talking about Docker Compose, which is like Docker sort of like automated. Next we're gonna be talking about how does model deployment actually work. And third we're gonna be talking about Third, we are going to be actually doing like a demo where I run a compose thing, where kind of like what you just saw, but with the actual API running. So first, let's talk about Docker Compose. So this is what we want to do. We want to have a Node frontend and a Python API backend. The Python API backend actually runs the machine learning model based off of whatever you input from that model, and the Node frontend is what the user actually uses to say upload the image or enter text or whatever you want to put the actual thing in there, so it's actually easy to use. And this little smiley face here is the end user. So we use a Docker Compose to run multiple containers locally automatically, okay? And so this allows you to make multiple services where you could say connect things between ports locally and then publicly on your environment or your actual PC. Those are you can actually see like one of those outside ports, so they're actually like sort of on the same computer, but when the Node frontend is talking to the Python API backend, we don't actually want to expose the Python API backend. So you can deploy these types of things publicly using Kubernetes. Kubernetes it's not like a hosting service like a Google Cloud Platform or Google Cloud Run. It's a actual technology that's used to scale and make sure you're only paying for what you're using on these cloud services. And there are other ones like the type on AWS. There's Heroku, and there's many more. There's a bunch of these because again, it's all open source tech. So wherever you want to host stuff, they pretty much just use the same software. And this is the front end that we want to do. You kind of just saw it. You just go and upload an image instead of running like a command line thing. You have like a whole user interface. So, oh yeah, and then, so we want the Node front end to send an image. Hold on. We want the Node front end to send an image, and we want the Python API to send back the classes and their weights. Does that make sense? Awesome. Okay, so for this container service architecture, we have the services, which are a list of containers to run at the same time and that want to communicate with each other. We have the web, which builds and runs the front-end container for the node. And the node container, there has to be a Docker file inside of the directory you specify here. So if you specify web, there has to be a web/Docker file, or else it will not work. And these, and the ports and stuff like that, that's kind of like when he was running the Docker run commands, it does all that -p and everything automatically, so you don't have to do it inside of a command line. So it's kind of like a configuration. Secondly, we have the API, which builds and runs the API container, which has Python and the machine learning model installed. And again, build must contain a Docker file. And there's 2 Docker files for this project. There's one for the Python, and there's one for Node. And then ports just maps which ports are passed through the actual container. And it's in the format host port, so the computer with Docker installed that's running the container is where that port's actually going to be exposed, and the container port, where if you expose something in the actual container sort of environment, you're basically mapping that container port to your port on your actual sort of host PC. So say you're running on like 3000, you can just change it to run like we did to 3001 on the host PC. Okay, and then finally volumes. So if you do this with volumes with the API/app, it allows you, so when you're actually developing, volume basically makes it so it's a shared drive space between your container and your actual host PC or Mac, whatever you're using. And it allows you, so when you save the files, it automatically updates when you're developing. So to run locally, there's, this is the link to the GitHub if you guys want to use it. But to run using Docker Compose, you just clone the repo, go into the repo, and run this command. And no matter what, it will work because all the ports and everything that you need to set up within the command, like Docker run, are in the configuration and they're already like done. So now let's talk about how does model deployment work. There's like the general machine learning pipeline is where you essentially prep the data, where you have a bunch of data and you don't know, and you want something, you have like a goal, you want something to infer from. That normally entails like normalization, like when you have an image, you take all the pixels and you normalize them between 0 and 1. Transformation, where you try and transform things, for example, in natural language processing, where you convert each word token into a vector. Validation, to make sure that the data that you have is actually correct. Like a lot of data that is available could either be wrong or copied, or there's a bunch of stuff that like you would actually have to do. And then featureization is kind of similar to like the natural language processing thing. But for example, if you have something like a CNN, a featureization would be after those like convolutions are run. So then you have the ability to build and train models, where you have where you can do like hyperparameter tuning, like changing how many epochs it's run, how long it's done. I'm not really going to go that far into that this time because we have other lectures on that, but that's the basic example. You prepare, you build and train the models, and then you deploy and predict the models, where you actually have like an API or deployment where you can input and it creates or generates an output, and it does batch scoring. Okay, so batch scoring is kind of like if you have an entire population of people, which is what I did a lot in my internship. You have like, say, an entire population of people, and you want to create a credit score for them every month. You would do batch scoring. You would run the first of every month, the entire set that you have, and then it generates a new score the first of every month, and then you check to make sure that those scores are correct. So the deployment lifecycle. So there's a difference between the pipeline and the lifecycle. Lifecycle is a model that you're trying to constantly update, and that's really important that it's actually correct. So first we define a business goal, which is a success criteria or objective for the actual model, where you say, okay, I want a model to do this. How can I do it? And by doing that, you do like a problem framing, where you say, okay, I have this input, what is observed, and then what do I want to predict? What do I want the output potentially to be? And then you find those sort of inputs, and then you figure out how to convert the data into a usable format. That's known as data processing, where say you have a bunch of text, you can't do like letter by letter. You have to convert things into tokens and give tokens like IDs and stuff like that. Second, you have the actual model development, which is like the building, training, and evaluation. During this, normally this is when the CI/CD pipeline is created for a model, where you have like certain like continuous integration and continuous deployment techniques to be used while you're making the model. And then you actually deploy the model into production. This is the main step. This is what we use Docker for. And then monitoring, which is what I did for most of my internship, where I monitored their machine learning models, and I basically evaluated them and told them to retrain or not retrain. So what are these other arrows meaning? We have development to data processing, this purple one right here. So say a developer makes changes to how the inputs are processed or to the inputs in general. Say he wants to add something else to the input of like a model predicting credit score. Then you have to, reformat all the data processing, the entire model, pretty much everything. You have to retrain, redo everything. So the other one is monitoring to development, where we backtrack. And this is when, like, say the hardware running is insufficient or is starting to error. And another reason that like you can backtrack in this life cycle is if the production inputs are different than the actual sort of ones that it was trained on. So for example, if you have like a recession, a score being generated during a recession will have a lot more, say, people getting loans than it was before, or a lot less people getting loans than before. So you have to sort of change over time and change based off of what your actual inputs are creating. And then the business goal to monitoring, where you're actually making sure that the outputs that these models are creating are not just random outputs that are based off of like nothing. You want it to actually mean stuff, and you want to make sure that it actually is achieving the actual objective that the model has. So a well-architected machine learning lifecycle has a security. Is there enough data for this model to be useful? How good is that data? Is that data like actually good data, or is it data that just kind of sucks and is like randomly generated? And there's a bunch of other types of security. Another one is like a usage restriction. For example, copyrighted stuff, or stuff that's private, like medical records or financial records that you can't use in a model. And then the other one here between a model problem framing and actual data processing is a cost optimization. You can't just add every input you want because you have all these inputs. You need to make sure that the inputs that you add are actually useful, otherwise you're gonna be spending a lot on compute that you otherwise would not be taking. And is the data actually necessary? If you give the computer a bunch of data, it'll find what's called a spurious correlation between stuff that doesn't actually like cause or correlate with anything. So you need to make sure that the data is like an actual independent variable to the output. Third, we have performance efficiency. How fast are these outputs actually being generated? So if it takes 30 minutes for an output to be created, nobody's gonna use it because why would you wait 30 minutes for a machine learning model to actually be made? And can it scale? That's kind of what Docker is used for. If we use Docker, we can scale it to as many machines that we want to run at the same time. Third, we have reliability. Reliability, are there changes to the actual input data distributions? I kind of talked about this. Is the model outdated? Is the data that the model was trained on outdated? Is there something different between the current data versus like the past data? Is the input being processed the same as when it was trained? So if the data is not being processed the same as when it was trained, that could cause a lot of issues. That's actually something that happened in YouTube a couple years back, where they went down because they had to retrain their a recommendation systems. It was new, granted it was 10 years ago, but that was something that happened because they were recommending stuff, and then it started recommending random videos that didn't have any meaning. So compare, perform. Oh yeah, so the actual performance, or how the model is actually performing, you need to make sure that it's not a lot worse than when you validated it during training. So if you have if you train a model and it performs 95%, you need to make sure that when it's deployed that it's still performing at 95%, or else the model's pretty much a defective model. And how does the model perform on outliers? If there's, again, 95% of them are correct, if those 5% are wrong, for example, if it's whether or not a company would go bankrupt in, say, a month, and they're doing it on 1,000 different banks, for example, on 1,000 different companies, then you're actually trying to find outliers versus trying to find non-outliers. Because if you're thinking of giving loans to all these companies, you're finding which companies not to give loans to, because they're considered outliers or scams. And operational excellence. How effective is our operation? Can we quickly make changes to our actual operation, or is it hard to go back and backtrack, see who's in charge of what's actually happening? And finally, does the model achieve the objective? Does it do what it was set out to do? Any questions? All right, awesome. All right, so for the deployment demo, I did out an API architecture diagram. We used the SciFar 10 dataset, and so this training portion is completely separate from the actual deployment portion because we don't want it to be trained right before it's actually deployed. We want it to be trained so we can restart or just have it completely separate. And that's where you actually take the data set and you do like the network construction and the hyperparameter tuning on the network. Then we perform a model validation to make sure that the model's actually generating what it wants. And then you can go ahead and save the model to a file. This file in the example is .h5 file, which basically just says what the network parameters are and what each weight is in that network. Secondly, we have the deployment, where you load the saved model. So this is actually before you start the API, you load the model into RAM, so you don't have to load the model every time it's being like run. Like when you call the actual API, you don't want to have it take 10 seconds to load the model before it like actually sends back a response. And then you actually start the API service. And when you start the API service, it sits there and waits for some user to actually request the actual API. So on a user request, you process the input. So you take what they inputted. So it has to be like, for example, the SciFar 10 dataset had 32 by 32 images. So you have to process the image so it scales down to a 32 by 32 image. Does that make sense? And so you have to pre-process this sort of image, and then you send it through the model to actually predict what the model says, and then you return the prediction. And in this case, a prediction is just a JSON object with the keys being the class and the value being the confidence. So here's the actual demo, the GAITOR demo. Let me see if I got this running. So for this demo, oh my gosh. Yeah, my computer doesn't like this. Oh my God. Yeah, when I updated my Mac, it probably screwed this up. It wasn't working before either.
You want to try on my computer?
Yeah, can we try on your computer?
Yeah, I think the
Yeah, I have the M1 Mac, so nothing ever works.
Oh no. Turn my computer back on.
Yeah, it doesn't even have Git installed. Why is it? It's been doing that to me for the past. That's why I don't know. Okay, but the basic idea is I have this inside of the actual GitHub. Cancel. So all you have to do is just clone the repository, go into the folder that you just cloned, and run docker compose up -- build. And -build just means that it will override, it'll do the build command for Docker, and then it'll run it on the actual Docker machine. And then you just go to localhost 3000. Oh. Okay. Sharing your screen. Awesome. Okay. Whoops. All right. Yeah. So just go to the terminal.
Yeah. I guess you can do everything
Can you-
from the VS Code.
Yeah. Can you stop this here? Stop these containers.
Yeah, sure. Just pause it.
Stop. Just so it doesn't screw up the. Yeah. Okay. So can I go from power? Well, do you know where it's held?
You can just do it in VS Code.
Oh, okay.
I'm already in there.
CD dot.
Yeah, just do cd.ls.
Yeah, so this is where this is where the Docker compose YML file is held, where you can just run Docker compose up. Wait, let me make sure something real quick. Okay, so I'll kind of walk you guys through the API running of this. So for this, I use Fast API. Fast API is just like you go here, you initialize. So this is how you load the models, where you have this model and its structure and everything built in, and it's in this .h5 file. So we just load that model first. And then we set what classes they are. We define a predict request, so I don't even think I use this, to be honest. Oh, this is, okay, yeah, I don't even use this, sorry. But yeah, you create a Fast API app, you add a middleware, which is like cross origin, so that's just like making sure. Normally you would have the actual like local host or actual API being run, and then you have allow credentials. So let me close this real quick. Okay, that's fine. And then you have get root. So this, I just say hello world on the home, and then yeah, we take this image, which is an uploaded file, and we read that image, and then we create a pillow image object, and then we check if the size is 32 by 32. If it's not, we resize, and then we check that the mode is RGB, because in this case, when the model is running, if it's black and white, the model is expecting a 32 by 32 by 3 vector, but if it's black and white, it's a 32 by 32 by 1 vector. So if it's not RGB, it will not go through the model. Then we just say that we create a NumPy array from the image, and then we define the types as float 32s, and then we normalize. So this was all we had to do before to pre-process those images from Sci-Far 10, but now it's just, we just divide everything by 255, and then we expand the dims to allow for like a batch, which is how it is predicted normally, but we only have one, so it doesn't really matter. And then we just output the classes and predictions in the dictionary, and then we convert that into JSON, and we dump the JSON as a string. And then in web, in src app.js, we define where we actually want to call it from, and then we define the headers, which we want to accept a JSON, and we want the content type upload to be a multi-part form data. And then that just renders the output like the table that you saw. And then when the image is changed, so on change, I set here to handle input. When the image is changed, it gets the input. It adds form data with the key image to the file upload, and then it creates a post request to the predict endpoint we defined up here, right here, and then it sends the form data, and it gives us the headers, and then .then just waits for the response, and then when it's actually the response is handled, we log the data, so I'll be able to show you guys what's actually being sent back. And then we set the output to response, and that will change the actual output. So if we go back here, and then we run docker compose up -- build, it should just build this out. And then if you do docker compose and you have multiple images and it hasn't built out one of the images or both the images, it'll build them out both at the same time. So it'll do all the downloads and the processing at the same time. So this is just installing the requirements. So for the Python Docker file, I'll talk about this real quick now that's doing it. We set the base image to Python 3.8. We set the working directory to app. We copy the requirements.txt file, and then we basically run an install on the requirements.txt, and then we copy everything that's in this folder here into the Python thing, and then to run the application we use UVcorn, which is just used to run fast API stuff, and then we define main app. So if you wanted to make multiple APIs, so if I go back to here, if we wanted to run multiple APIs, you could do like, you could create a variable called app2 in here, and you could run multiple APIs from the same folder as well. So that's an option. And then this one here, and then -- reload means that if you save a file, it'll sort of automatically reload. This host sets it so it is allowed to take in requests outside of its local network. And then the port, it sets the port that's being exposed to 8,000. So I guess while we're waiting for that, let's go to this. Let's go to here. I talked about this already, but now you can see the file system, the services right here. This web service if you go to the folder web, it has a Docker file, and then that's what's being built. Whatever's in this Docker file. Same for this one here. So this web build inside, the API build. The thing that's being built is this container with this Docker file. It's taking forever. But yeah, are there any questions? Does anybody have anything? Anything on like the deployment pipelines, or because that stuff's honestly really important. Yes.
From the presentation, what were you saying about the prediction exactly? Like, what's that founded on?
So the prediction is based off the model. So a prediction is like if you have like a model and you have like certain inputs. So let me go back here. Right here. This one here. Were you talking about this here?
Yeah, that thing.
Yeah, so the actual prediction is so you input the image and then it runs through the model. So if these are like inputs, it goes through all the layers that it needs, and then it predicts, say, like it's like a 5% chance that it's a dog, 2% chance it's a cat, and like a 90% chance it's like an airplane. So those predictions are the actual like output of the model. So it's what was being trained. It's doing what it was trained to do. So the prediction, and if you don't know a lot about machine learning models, there's is it done yet?
It's still working.
Okay.
I'm trying to get an image for you. Probably like a dog picture or a cat pic.
Oh yeah. Probably like a dog or a cat. It's best on airplanes and stuff like that.
Oh, okay.
I don't know why my Mac for some reason doesn't have Git. But all right, I mean I'll host I'll host this demo on Google Cloud build for you guys to try it out. I actually really suggest, because it's so easy to run it, I suggest you guys go to the GitHub, clone the Git repository, and then just run Docker Compose up inside of that folder, and it will work just like that. If you actually have a computer that works with Git and like everything. So yeah, I think that's about it.
Yeah, I mean, it's still loading.
I wish it worked. I don't know. We don't. It wasn't. Is it still getting requirements?
Yeah. I mean, you guys have any questions for me or anything? Oh yeah, just on a note of ACM, if any of you guys are like interested in hosting or leading a workshop, go in our Discord. I think I made an announcement about like hosting a workshop, and just apply. Later this week, I'll be sending out emails about hosting and leading workshops with anyone who wants to do them. So if you're interested, just apply, and I'll get in reach or in touch with you guys later this week.
Awesome.
Thank you guys.
Yeah. Thank you. The stream was a little scuffed to begin with. Sorry about that. My computer decided it was a great time to update, and then the update made it so it didn't work. So yeah, that's it.
Just a quick question. Have any of you guys like used Docker ever before, like in an internship or just for fun? Do you guys think you'll be using it now to like make your build or development cycle like more productive, or probably just be doing it like the basic way? Just have a local repository on your computer, just put it on GitHub. Do you guys think you'll be using Docker in the future? I'm just curious.
I use Docker every day.
Yeah, I had to use it for a software engineering class.
Oh,
Oh, nice.
okay.
Yeah, no. Yeah, if you guys don't use Docker, it's just a great way to organize everything. Keep everything in one container. So, all right, I think that's it. Thank you guys for coming. It was fun. I'm sorry we started late. That was unfortunate, but yeah, if you guys want, I'll be here next week doing, I think, Transformers. Me and Patrick and Al are gonna talk about Transformers, which is gonna be like a key lecture, because Transformers are what Bert used and DALL-E 2, well, a version of, well, the pre-processing portion of Transformers.
I think ACM will be holding Lead Code this Wednesday. So if you want to practice some like Lead Code problems or anything, just pull up. We'll be at the Fishbowl. We'll make an announcement pretty soon.
All right, awesome. Thank you guys. Yep.